Welcome, welcome. This is incorporating AI into your classroom. My name is William Avendano, co-founder of Zero One, coming to you live from my apartment, thanks to COVID-19. I hope everyone here is well. Hope everyone's had a wonderful time at the virtual Maker Faire this year. And we'll just get started really quickly. I know everyone's like we started a little late, but we'll breeze through this really quickly. I do see some familiar faces in the participant list, so it's good to see you guys. And then I'll just begin really shortly. So a lot of what we're going to be doing today is how to understand AI, how to have conversations about AI in your classroom with students as young as kindergarten to as old as 12th grade, and incorporating these ideas in a holistic way throughout different things, projects that we've done in Zero One, incorporations that we've done in different classrooms across city of Miami, and different projects going together. A little bit myself. My name is William Avendano. I'm a co-founder of Zero One, and we are an education laboratory based in Miami. And our focus is to foster agency and creative confidence in people by empowering them to shape their world through emerging technologies. And what does that mean? It means allowing them to really engage, explore, create, and kind of derive meaning from different spaces that they can work with through technology that they're interacting with, create new ideas from the things that they're working on, and how they move those things forward to be able to design projects, think of companies, et cetera, et cetera. So we've had students do things from designing their own skateboard companies to learning how to operate machinery in Moonlighter, or opening up gates with their mind using brain control interfaces and Arduinos and radio sensors. So a lot of experimentation. We allow it to kind of be a space where a lot of things that we don't know, we don't have the answer to, and we kind of develop it with these students. And our goal is to help foster in this lab space the idea that we can create lifelong learners. And this is my business partner, Nelson. And we start with this exploratory notion from a very early age in this holistic sense of building structures that we can build upon and go forward with that allow us to really think about bigger things in a more easy to digest way. And we kind of think of these modalities in three major topics: play, the interactivity of exploring, trying new things without the repercussion of some homework or assignment to do so, and being an 8-year-old and jumping into virtual reality for the first time and having that kind of carelessness to it and carefree nature. Code, what we would call just the infrastructure and putting things together of the things that you've been exploring and kind of trying to codify in some regimen of how we put these things to, like, these new exploratory ideas and new ideas together into something new. This is a game designed by one of the students. And design, where now that we've codified these things, we are now ready to produce, reproduce, and make these ideas vivid and long lasting. And this is actually inside of Moonlighter Makerspace a few years ago, as some girls were deciding to design their game, fabricate it, and put it together. So it allows for our lab space to be exploratory, experimental, a little bit crazy, but it breeds the room for different ways to think about technology altogether, with playing Minecraft to working with AI. So I'll give you a little video preview of what we've done in our lab space. So today we're going to talk a little bit about a framework that allows us to kind of communicate these ideas. One that I've been seeing from different places, and great to see some of the faces there from CSTA. A framework that's been developed over the past uh, few years and really codified this last virtual conference at CSTA, which is the Computer Science Teachers Association, of an interesting way to think about holistically bringing about AI into the classroom for all ages. And it's a group putting together what we call AI for K-12. And I'll present my talk through the lens of this framework as it helps kind of set the tone for the direction of how to think of these 5 different areas that they've outlined to kind of understand and talk about AI in a more tacit way. Let me, so some of the things that I will be using from here is courtesy of AI for K12.org. Their presentation, K12 Guidelines for Artificial Intelligence, is available on their GitHub. I'll put the GitHub link a little bit later in the slides, but David Tereski has been put together tons of resources and an entire community of resources and activities to use across different grade levels. Right here is their GitHub link, and they make their wiki and communities page available for everyone to use with resources for different grade level bands, progression charts, and just events that you can go through, papers, a research directory, a lot more different things. If you take a screenshot and QR code it, you'll be right there. So why now? Why talking about AI? It's definitely a hot topic. It's definitely something that is becoming more and more prevalent. Some people even think it's politically prevalent to kind of curtail and think in these different ideas that more along the lines are scaring people away from jobs. People are seeing automation coming firsthand, job loss in some areas, the advent of intelligent assistants, self-driving cars, more prevalent, more robots in the workspace, in the home. And there's a growing need to not just understand what these things do, understand how to mitigate against them, how to solve problems in AI, how to solve problems that we don't know how to solve, and how to interpret those different things in a way that maybe we won't be under some hegemony or something with AI. So it becomes like an interesting metaphysical conversation that you want to hold, but by allowing students to get into the black box from an early age, you're opening up this conversation young to see how do these things affect what we're doing today. A great piece is When Computers Decide, and this is also courtesy of Miles Berry. They believe that virtually everyone needs a basic understanding of these technologies that underpin machine learning and artificial intelligence. And it's not only just coding or design, it is a lot of these different facets of understanding how do we as human beings think and how do they apply to these machines, and how do we interpret for those ideas. And what's great about this framework is that it really breaks it down into 5 different layers of how to understand artificial intelligence the way you would at the college level, and how to take those ideas and break them down into a way that's really digestible for other people. So their mission is to develop guidelines for teaching AI in K through 12. It's modeled after CSTA, and no wonder they are a huge partner in this initiative happening. Multiple bands of how to interpret this technology from K through 12, K through 2, 3 to 3rd to 5th, 6th to 8th, and 9th through 12th in the high school, of what students should know and what should students be able to do. Have a resource for people, and then create a community of other educators across the US and across the globe on how to incorporate these ideas. And it's no wonder that it's a joint project by CSTA, the Computer Science Teachers Association, Carnegie Mellon, the Advancement, uh, the Association for Advancement in Artificial Intelligence, even with funding from NSA. And like the board that underpins this goes even further with working group members from MIT, Google, AI for All, board members from Roham University, UC San Diego, the Milwaukee School of Engineering, Microsoft, IBM, ISTE, and just to say a few really quickly, like this is a huge consortium and it only makes computer science education that much more tacit. This is another slide based from the presentation, and it shows that computing in K-12 globally has its roots in different areas, like what Israel has been doing since for 20 years, what the UK has done in a really national mandated program, and what were things we're doing in process here in the United States, like CSTA, CS for All, Code.org, and the number of programs that already exist to help enhance computer science education. But in these standards, even just as recent as 2017, there's only two things that kind of force themselves on how to think about artificial intelligence, how they drive the software, and how to play a game against a program. And they're geared towards 11th and 12th graders. And nowhere do we have this conversation early enough to young students, especially children that we've been working with for the past couple of years in that 7 to 14-year-old range, on how to really create and tinker with these ideas. So we come from this maker mentality. We come from this very like DIY methodology. So to see this in a codified way was very disheartening. So it made sense to go along and with what this framework is going through. So the framework breaks out into 5 big ideas on how to view AI and how AI is kind of reflected in these normal ways through perception, representation and reasoning, learning, natural interaction, and societal impact. And these 5 ideas kind of give way to why they're important, how they're important, which ways can we talk about them in a holistic manner, and what is their impact to us going forward. So I'll use this as kind of like my story arc for how we've done projects going forward. The first big idea is perception, the idea of using computers to perceive the world using sensors, to extract meaning from these sensors. And it's really interesting. One of the experimental projects we've done in our first year in that lab space was use OpenBCI to connect sensors, remote control sensors, from one student's mind to a gate and use that as a remote control relay, so that when triggered with the right brain waves, the brain computer interface will trigger us the remote control relay and thus open the gate. And this idea of perception allows us to really think about what is it that these machines are able to understand and glean from the information given to them, and what do they interpret? What are they seeing? What are they putting together? So based on this, we're talking about speech recognition, what computer vision is, facial recognition, object recognition, license plate readers, and different kinds of perception, using sonic recognition like Shazam, or interpreting sonar, radar, and LiDAR. So we use this to kind of segue into conversations of interesting tech out in the world, and thus brings us to a hot little dog for those of you guys who are interested. Spot Mini is a robot designed by Boston Dynamics. It is currently available if you have the cash for, I think, $75,000. And it is a robotic dog. It's able to carry things, but with sensors all over the place. So we would have conversations, and it'd be our segue in our camp programs to talk about how is information coming in to these robots. It's walking, running, how's it able to see and map through everything, and understand where is it getting its information? So we're using this as a conversation point to really introduce, here's how these peripherals to our basic computers get information. Here's how these sensors and perceptors really bring in information to this machine and allow it to understand and make the decisions it needs to walk, jump, not fall, et cetera, et cetera. And you've probably seen every great Boston Dynamics fail video. And if not, I definitely recommend you to watch the litany of them after this presentation. So because of that, we thought it'd be a great project to take this further a little bit. We don't have as many good videos from this as I would like, but we took this to create, and all the researchers are here, to work on and develop a donkey car. So a donkey car is an open source RC car using OpenCV to navigate where it's going for its self-driving capabilities. It is run on a Raspberry Pi. So those of you guys who may not know, it's a $30 computer the size of a wallet with the power to boot. And it's a completely open system. The parts get to about $100, $150, $200 maybe, with 3D printed cases, maybe the wheels and the motors and the battery drivers all together. But this is 3D printed here. And we designed this probably within like a year with a high school student to have a full open source driving, self-driving car. And it's something that I'm going to plug for tomorrow. Actually, my business partner Nelson was talking about open source technology and how it impacts the projects that we work on. And he'll go and talk more about his project that he worked with on this. But we designed and created this open source vehicle. And the conversation we had after the fact with the rest of our high school students that were on this project is, now what are the sensors doing? What are they allowing us to interpret? What is the CV telling us about the world around us? What do we tell ourselves about the world around us? And now it becomes a sensory conversation that any second grader can definitely pick up and go forward with. The second idea from their framework is on representation and reasoning, where agents maintain a representation of the world and use that to understand it. Comparisons, contrast, taxonomies, right? And this gives way for our idea of classifications, which is a huge important part of how machine learning does its job for iterating and understanding what the world is around it. So we have a simple taxonomy of literature and how these subcategories lend space for other subcategories. And right here we have a little image of AlphaGo. It's Gray Battle with Lee Sedol and the epic program that showed that AlphaGo was much, much better and efficient than any human player was ever able to be at the game of Go. So some of the examples of some of the examples of these programs incorporate path planning for self-driving cars, understanding these spaces and which may be the best route. In the same conversation, we go back to Spot Mini describing spaces, and in the video that we showed together, how to Spot see the world around it and use that information to create the best path for it. What things are safe, what things aren't safe. The same with a Tesla, what things are safe, what things aren't safe. We do the same thing with Waymo and other self-driving information to see, okay, how do these now sensory information that we've received, now we create a representation to understand, okay, here's what the world is around it, how games are created. And in this portion, we would work through designing our own games and understanding strategies, writing through strategies and saying, how will we best find the way to win? Or how do we best find the most tacit way of producing something, the best outcome? And how do we create these to go through it? Notes on this. So types of representation, types of algorithms that we can go through, types of search. types of school bus routes. And now we take this idea and now we're trying to ascertain information from it. Now we're on the translation layer where we're able to go from one idea to another, and now convert this into simple yeses and nos or ones and zeros. And now we can create what we would say like a representation tree. And this was an interesting activity that I did. I did it myself from my head, and I saw it again replicated on the framework, and it was just surprising. So we took the animal kingdom and kind of laid out with third graders how different animals classify themselves. Some breathe in air, some lay eggs, some have air, some are pets, some have wings. And if these classifications match themselves, it becomes the vector for representing each animal. And we do that, and this is how we understand each characteristic, each nature that not just these animals have, but every single piece of information has in a larger matrix of information without having to go through the rigmarole of teaching matrices to students. The idea that it's a chart of information we can just jot through and create a representation table allows us to really understand and see, okay, here's what I can figure out. If I can't breathe air, must be a fish. If I lay eggs, it must be a bird or a lizard or like some kind of amphibious animal. And if not, it's probably a mammal. So these representations allow for younger students to think about how machines are understanding and learning this information to go through and make the next step, which our next slide be based on that. Learning, where now it has the data, it has computed this information, and now it's not just taking the computation, and now it's iterating on top of that to infer and make decisions from that. So as we go through this procedure of machine learning, we've taken the information from our perceptors, we've processed it into a way where we're able to classify them, and now we'll do the activity of understanding what this machine learning is actually doing, how Netflix learns what movies you like based on the classifications you've given it before. I like action movies, so I'm going to rate it a 5, but I don't like rom-coms, so I'm going to rate it a 1. And based on that, it learns, let me give you another action movie, or let me not give you another rom-com. And these conversations are what allow themselves to really go through and introduce a KNN without these methodologies. So speech recognition or translations or a classifier, and these tasks in different ways. So one tool that's really fun to use, even for younger students, and that's with the 12th graders as well, is Google's Quick Draw, where its neural network can learn to recognize what things are based on a doodle. A great example is being asked to draw a snake. I'm a terrible drawer to begin with, and every time I begin to draw something, it became a figment of hysteria for each of the younger students because they would see how terrible my drawings were. But then as we saw the results and we saw this pain right here, which is what you get after the fact, you see what else it thinks of your drawings to be. Not just a snake, but the Great Wall of China, a roller coaster. And you see other drawings that it learned from. It takes the perceptive information from other snakes that were drawn correctly or other things that it figured to be snakes and uses that to learn it. And how did it figure it out? Oh, it's shaped like an S, has a tongue. And now that we're able to glean and add information one by one on top of these different layers and have this conversation that we're able to add onto it, you're able to see, okay, now we understand as young as second grade, how does it learn that these things are snakes? The same way it quizzes itself, and we go through the idea of like talking about how it quizzes itself and learns the different things. For more advanced students, we've done things like the Muddy City problem, where we would show how to travel to different things, or the bridges of Koenigsberg and how these learn the different things. And this is actually a really cute activity that they highlight in this course about how to classify this information. You see all these different things: lollipops and chips and fries and ice cream and chocolates, or kiwis and broccoli and apples and lettuce and asparagus. And we want to train our machine to give us healthy food, or to figure out what's healthy and what's not healthy. So our first step would be, okay, let's group what's healthy and what's not healthy. Chocolate, it's healthy, but not necessarily so. Chips, definitely not. Ice cream and fries, definitely not as well, or neither is lollipop. So now that we've bundled these groups together and made the classifications for them, students are able to understand and say, hey, these things are one, these things are not. And now we take the next step and run iterations and tests against these. Now that we have our training sets of what is healthy and what is not healthy, without having to use words or vocabulary like training sets or training data. Now we're able to use these pictures with a great program that I'm going to show you now, called Teachable Machine, and see, is this green gummy bear healthy? So what's funny about this setup is that it gleaned that everything that's healthy has green in it. So therefore, it sees that our image of our green gummy bear is green, and therefore it's healthy. Now, it's not really healthy, but it learns that all these other things aren't healthy, and therefore these things are healthy by the specifications, and thus. And Teachable Machine is a great tool to interact with students and get them to use a webcam or pictures inside to train students to make these training sets with pictures or with different things like gifs of cats waving or highs and hellos. And there's another one that's right after on like rock, paper, scissors, all in the browser with no writing of code at all. It's just kind of setting up these data sets and using them to train against these different ideas. And then by doing so, it trains the machine inside, and you're able to show these activities in actuality. So rock in all its different forms, paper, and scissors. And then when you show the webcam rock, paper, or scissors, it's able to learn and glean what happened in that sense. And an interesting other thing that we've started experimenting with, some of my older students introduced to me about a month or so ago, which is a neural network platform for Minecraft, separate from the one that's actually being developed internally by Microsoft. And if I have any questions, I'll send the links for that as well. I didn't post it in this presentation. That's called Project Mammal, but this is a modification to Minecraft called Chaoscraft, where there's a whole video series of this open source developer doing this, but essentially it's allowing for the perceptors of characters inside of Minecraft to do things like create their own houses, farm their own resources, et cetera, and allowing these perceptors to be generated and create the classifications to do the actions necessary to see what things are mineable, what things are not mineable, what things are safe for you and what things aren't safe for you, and creating these like natural modifications. So we've been testing it actually on a separate server that we run. And it's me and like 3 other high school students that we're working through and kind of training the models to get to this level. So if there's more information, this whole video series is right here. The fourth idea of this presentation is natural interaction. So intelligent agents that we communicate with to allow us to interpret what we're saying. So now that it knows how to sense information, it knows how to classify and categorize information, and now it knows how to learn from the data to do it. Now it has the knowledge, it needs to receive this knowledge, this question or this interaction from us from request. As simple as I may say, hey, name your assistant that I don't want to alarm right now since we're on the call, get me the weather. And how it's able to perceive this notion and use that to ask for your request, use the challenge to make that search or that call, or so how to introduce natural language processing without going through toolkits and grammars and contexts, things that most computer science students in college struggle with, the notion of how to design languages that have contexts and grammars, and how the linguistics of one language and the way the order of words in certain ways allow machines to know one thing and know something else completely different if said in a different order. So how do we explore these interactions with things like Alexa and Siri? How do we have conversational agents like chatbots on our website and things like that? So one of the things that we did in our experiment, in our pace, was actually DIY our own Google Assistant. This is an AIY project from Google. It's their do-it-yourself kits. You could get this at Target for like $100, and it comes with the cardboard and a button and a speaker and a small Raspberry Pi Zero W that you can connect, and they help you set up everything. So we did this with a couple 10-year-olds. We got the kits from Target same day, and we started building this up, and essentially builds out your own Google Home Mini and allows you to connect and ask for simple things like the weather, or connecting like what the sports score was. And the big project that we had was getting students to actually get it so they could play Spotify. So they wanted to connect Spotify to it and allow them to ask their assistant to play a song from Spotify and go through this. They press a button, and the button would create the relay to connect, and so listen to the microphone, receive the microphone information, interpret that information, understand it, classify as what the thing it's asking for, make the search, bring in the information. So it simplified down this entire train necessary for interpreting AI in this odd way with a simple project that we built together in about a couple of days. So some of the things like affect, interpretation, voice, linguistics, things that are really difficult to interpret and understand with natural humans, how to bring that into an interaction space with robots. So the other thing that we would do is we create a chatbot and two different setups, where we would have one of those create your own adventure games, and not intuitive, just like how to able to like make decisions, classify the decision, and then create simple choices from that. Go through and design our chatbot programs, and they'd be simple Python programs that we do with our middle school students, and then we would talk about the things that were happening are on the level of GP3 or GP2, and the things that are innovating on AIs that have the ability to read every document and like be trained in these documents and understand grammars and put these things together. And we would do adventures where we would use AI Dungeon to create interesting stories together, some of them that never existed ever, and use this to understand like where are these trains of information following, how are they understanding these things, how are they putting these together, and use that to kind of map out an interesting story that's being developed from this information. The last bit that they focus on is on the societal impact and how different artificial intelligence will change our interaction with the world. As you see in the kind of dopey picture they have here in the left, no one's driving a car, and we have the dog sitting in what would be the driver's seat in a completely self-driving car. Or we have robots telling workers to go somewhere else because they've been taking over the full automation. So how does automation affect the spaces that we're in? How does the companies that are the most powerful at artificial intelligence integrate how we're doing and understanding what we're actually working on, making those decisions for us? The five big companies and their impact on these things, like Facebook, like Google, like Apple, like Microsoft. How are they guiding our decisions and allowing us to see what's happening in the world, view their importance? What are their ethical ideas on these things? And they see in the way they design this notion is that the societal impact is at the core of how artificial intelligence is interpreted through all these lenses of how they're impacted, how we interact with these computers, how we perceive these computers, how computers perceive us, how they understand to represent and reason through what we are, and how do they learn from these things. And this is where a conversation with as young as kindergartners can be about biases and uh, and things of um, transparency and accountability. How do we know that it was trained appropriately with the right data set? How do we know, like in our example earlier with the vegetables and the healthy food and the not so healthy food, how do we know that we didn't give it enough training data? How do we know we gave it too much training data? This is these questions of ethics that become endemic to not just understanding society, but understanding how society is moving separately and separately. Do people feel comfortable with having an assistant control the things around them? And use use this conversation as a segue to interpreting fairness, privacy, data. It becomes a segue into cybersecurity. How likely are you willing to give someone else those value trade-offs of give someone else your data insofar as you're allowed to do something else? Um, Something about robot servants or unintended biases that may exist from these notions. And there's a great Google Doc linked here in this slides, and I'll have them at the end of the link to the slides will be at the end, with a great Google Doc on AI and ethics, and it's garnered towards middle school students on talking about ethics in different ways, how, for example, YouTube is serving ads to certain kinds of people, or YouTube is blocking certain kind of videos from being seen by certain things, and how do we allow these algorithms to really dictate what we're seeing or what we think it thinks it should be showing us, or serving to us. So these questions that we take for granted, even as adults, how do we parlay them into conversations we have with students? And I think in the general scope, the guidelines is to be transparent. It's not a black box. I mean, it's not magic. Nothing scientific is magic until you show them what's inside the black box. Um, have conversations and be open about how things work. Creating mental models, which has been something that has been endemic to teaching computer science from the beginning, and using those models to see how things relate to the real world, and then encourage students to develop with applications like one featured here called Cognimates, a few others I mentioned with Teachable Machine. This is actually a really interesting one I found the other day called AI for All, and this is one that was suggested to me by my high school student. Things like Colab, things like even Scratch Junior or Minecraft, things that we already have access to that allow us to really bake these all together. And without further ado, if you have any questions, I will open the room for questions now. So just raise your hand. Since we started a little late, I'll leave the room open for other things per se. all I have to do, I think the raise hand command is on the participants. If you,
Yeah, it's hard to find it.
yeah, it's right next to the more tab. If you press more next to your name, you'll be able to go in and raise your hand. And then, but if anyone just wants to talk out, this is a small group, we can just go through and then.
So I missed the first half of it. I tried to get in earlier, but could you zoom in on the link to the slides you had on the previous?
Sure, surely. So it's just bit.ly MMF 2020 AI Classroom, and then I'll copy this also into the chat as well, so everyone has it. Any other questions? No, no questions.
Well, sorry,
All right.
the clock was on. That's my bird clock. It's not very aware. It's not self-aware, unfortunately.
GitHub address. Yes, I will post it right here. I know I sped through it. I apologize for speeding through it. I realized we missed like 15 minutes by just having like the wrong Zoom links. So I sped through everything really quickly. And I'm going to post this in general as well. The GitHub this is the GitHub link to David Turetsky's wiki for the AI for K-12 framework. And I'll just open it up now so you could see it in a more tacit way. This is the organization page, but right here are keynotes, events, the mailing list, a progression chart that's really good, a like poster kind of like highlighting the things we just talked about with the five kind of like procedural moments, tons of presentations in the last 18, 24 months on introductions of different things. There's really good, this video right here on Teachable Machine is really, really helpful from RoboFun, a great organization in New York. And what else? There's resources. They had a lot of information in the recent CSTA conference, which happened this past July. So a lot of the recent talks here are from that conference. Birds of a Feather, Teaching Ethical AI, Learning Activities for 6 to 12. These are all fairly recent, and most of these resources are fairly recent. If there's any questions, I will also put my email address here in the chat. Feel free to reach out to me. I right now I mostly teach high school students, so 9th through 12th grade, and we're going through AI and through Chaoscraft. We're also working in Colab as well, Google Colab, which is kind of Jupyter open sourced through Google as like a Google Doc format. We're able to run a Jupyter sheet in Python to run AI in different ways. But as you see, that's the most technical thing I've shown at most here. I'll zoom this in a little bit so you're able to see. And then Colab. And Colab is more of, you have free access to their GPUs. You're able to run what's like a Jupyter notebook on the web and do data science and run actual visualizations. Those of you guys who are science teachers as well may even want to do this for like science reports or understanding data in different ways. This is a great resource. And then I'll show Teachable Machine really quickly as well. and they just upgraded this version of Teachable Machine actually. This is V2, and they have a V1 version as well. It's it's very modular. They've actually incorporated like more features like um, body motion, sound distilling, a lot of different areas, and you're able to make classifications, train your model, and then use that to try different things. And it works not just for pictures now, it works for sounds, it works for, I think, not videos, but apps, tons of different notions. And it's without having to write a single line of code. And it's more about kind of going forward and taking this information to go through this and like using training to infer different ideas. And Teachable Arcade's a really great tool right here, and then Teachable Machine in the D School. So this is their previous version. This is their V1 of Teachable Machine, which is what I've been using traditionally to like train Purple. Lets you train green, purple, and orange to see different kinds of views right here. So I'm gonna actually close this because it's gonna stop my camera. So without further ado, I want to thank you for coming. Thank you for listening. Feel free to reach out if anything. And I hope you enjoy the rest of the Maker Faire.
Thanks. This actually looks pretty interesting. I'm going to follow up on this link.